Okay, we're going to have a look at some of the reactions that we can do with the alkenes. So, quick reminder of what an alkene is and the basic structure and the functional group. The example we're going to use is ethene. So let's quickly draw that out. Okay, so ethene has 2 carbons in it. This is the simplest of the alkenes. So let's draw our 2 carbons. And because it's an alkene, ends in ene, then we need to have a double bond between those as well. Just remember that each carbon can have 4 covalent bonds. So carbon number 1 has 2 already, so there's our other 2. And this carbon number 2 already has 2, so there's the other 2. So there's 1, 2, 3, 4, 1, 2, 3, 4. Add in your hydrogens because it is a hydrocarbon, and we've completed the structure. To write down the formula, we've got 2 carbons again, so C2H4. Simply count them all up. What we're going to do now is have a look at 3 different reactions with ethene. The first one we're going to look at is a reaction with some water. We're then going to look at the reactions with hydrogen, and then finally we're going to have a look at the reactions with chlorine. More on that in just a moment. Now, when we say water, the conditions have to be hot enough. So really, you might hear the name steam being used instead, but we do mean water. It's important to just sort of be aware of the structure of a water molecule. We've got 2 hydrogens and an oxygen that are covalently joined together. And what happens is when the conditions are right and water reacts with ethene, what the conditions do is they break the double bond. Now, when that double bond breaks, it can form 2 single bonds. So I'm just going to show you how the structure of this changes when the double bond breaks and we form 2 singles. So let's get our carbon sorted. So there's our carbon. We're going to break the double bond for it to become a single bond. And what I'm going to do is I'm going to keep these 2 hydrogens where they are. And then the 2 hydrogens at the bottom, I'm just going to shift them around a little bit because we need some space. The 2 new single bonds are now here and here. And we still get the same rules apply. Each hydrogen has 1 covalent bond. Each carbon now has 4. It's just that I've got space for 2 more things to attach, 2 more covalent bonds to form. With the water molecule, one of the hydrogens joins to form one of the bonds, and I'm left with an oxygen and then a hydrogen. So the oxygen binds first, and then we get our hydrogen. And the reason it has to be this way around is because oxygen can form 2 covalent bonds and hydrogen can only form 1. So let's quickly check and make sure everything's all in the right place and we've got the right number of bonds. So carbon number 1 has 1, 2, 3, 4. Carbon number 2 has 1, 2, 3, 4. All the hydrogens have 1, including this one over here. And this oxygen has 2 covalent bonds. So everything's in the right place now. And this is the reaction that we form. And ethene, when it reacts with water, it then forms an alcohol. And to name the alcohol is really easy. We take the first part of the name of the alkene, so it's eth or eth. And because it's an alcohol, we then call it ethanol. So we just changed the name at the end from ethene to ethanol. Next process, again, forms in a very similar way. So we're going to break the double bond, but this time instead of reacting with water, we're going to react with hydrogen, and a hydrogen molecule has a single covalent bond between it. Let's do the same process. So we take our carbon double bond, break it into a single. We then just shift around the hydrogens to make a bit of space. And then we've got our space for our 2 new bonds, which our hydrogens take up. And again, it all matches up. Naming again, this time we've gone from ethene, so it's still eth because we've got 2 carbons. But now what we've done is turn the alkene back into an alkane. So this is simply called ethane. Again, all of the alkanes end in ane. Now the final one's a little bit trickier. Really, when we're using chlorine, we're actually using one of the halogens. So this is any one of the elements in group 7. So have a look down in group 7, you'll see sort of chlorines in there, fluorines in there, bromines in there, and so on as well. I've used chlorine just as an example, just to sort of talk you through how it happens. And the structure of chlorine is very similar to the structure of hydrogen in the fact that it forms just one covalent bond, so Cl between the two atoms. And exactly the same thing that happens in this reaction with the halogens as we did with the hydrogens again. So we break the double bond, carbon-carbon, all the others shift around. There's our hydrogens again. Nothing to, hopefully you can see a pattern happening here. And then the two new bonds form here and here. So we're going to have the first chlorine, its double bond breaks, one forms here and the other one forms over here. Now the only tricky part is the naming bit. It cannot really complicate because the word's really long, but you can break it down into smaller parts. You can see that actually if we compare ethane with the structure of this molecule here, they're pretty similar. The only difference is we now have chlorine instead of hydrogen. So we can still call it ethane, but you can't just call it ethane because it's got two chlorines in there. So instead of saying two chlorines of ethane, what we're going to say is we're going to say di for two, chloro, and then ethane. So dichloroethane, two chlorines and ethane. And that's how we name the product when we react with one of the halogens. So here's your overview, really simple. 3 reactions, one with water, one with hydrogen, one with chlorine. The objective is to break the double bond. That then allows 2 single bonds to be formed. And again, the other molecule, the other atoms can attach in the appropriate places. Have a go yourself now. Instead of using ethene, try with one of the other larger molecules such as propene or butene.